The magnetosphere is a region of space surrounding an object where the motion of charged particles is dominated by the magnetic field of the object. And so if we have the Earth has a strong magnetic field, and as a solar wind comes blowing past the Earth, the magnetic field diverts the solar wind around the Earth, sort of about 10 Earth radii in front, and then the solar wind drags the Earth's field about 100 Earth radii down in what's called the magnetotail. So the Earth's magnetic field sort of protects the Earth from the solar wind particles by diverting them around, and only a small fraction of those particles actually enter into the magnetosphere. Yeah, so the magnetic field connects the magnetosphere with the ionosphere. It's sort of like a conduit that carries currents and particles between the magnetosphere and the ionosphere. And much of the activity in the magnetosphere maps to the ionosphere, and the aurora caused by precipitating electrons is sort of like a window that we can view what's going on in the magnetosphere from the ionosphere. The magnetosphere itself is driven by the solar wind. The solar wind has a 11-year cycle. Then there is the time scale of storms and substorms. So the storms are caused by like coronal mass ejections coming from the sun, and those happen maybe once a month or so. Whereas substorms, even if you drive the Earth at a steady state, the internal dynamics of the magnetosphere sort of like store and release energy, and that's about every 3 hours. So substorms occur every 3 hours. And then you have daily dependence. So as the Earth rotates, you receive most of the auroral activity on the night side near midnight. Then on a faster time scale than that, we have so-called PC waves, which are like 5 minutes to 1 second period, and these might be waves that are on the boundary of the magnetosphere or like breathing modes of the magnetosphere. As an example of how space weather can impact our life here on Earth and infrastructure, between October 23 and November 6, 2003, there was a series of storms called the Halloween storm. And during that time, 47 satellites reported malfunctions, and the Midori satellite, which cost $640 million, was a total loss. And more than 10 of these satellites were out of action for more than a day. So another example of the importance of space weather is a disaster that happened in February of 2022, when 38 Starlink satellites were destroyed by a geomagnetic storm. And how that happened is that there was heating of the ionosphere raised up, and then the satellites going through the ionosphere overheated.